Over the years, the aviation industry has undergone significant changes, mainly to the technological department, whereby some of the most notable ones are the implementation of the fly-by-wire system, the usage of composites, as well as the implementation of Wi-Fi on board. However, the expectation of what people expect from technology 10 years back is vastly different from what we expect of technology now. Mainly it's because of the ever-changing nature of technology, the fast pace of the change of technology, in which airline needs to keep up with, or they risk falling behind. I would say that the most important one to date, the most important advancement in technology is the usage of composites, whereby Airbus has the A350 XWB, while Boeing has the 787 Dreamliner, in which they both boast around over 50% usage of composites on the aircraft. The history of the usage of composites on aircraft. Well, the first aircraft that has ever used composites on its structure, on its body, was back in 1916 in World War One by the British, in which the name of the aircraft is the Bristol Scout. As for today, the usage of composites on Boeing aircrafts as well as Airbus aircrafts can be dated back to the 70s for Boeing aircraft and to the 50s for Airbus aircrafts. For Airbus, the first time that they used composites on their aircraft was back in the 50s, in which they used it on the A300, on the radome and fairings of A300. While for Boeing, back in the 70s, the first aircraft that has used composites for them was the Boeing 707, in which they utilized fiberglass. And undeniably, the usage of composites has grown ever since that people know what composite is capable of. In which, as I said earlier, Airbus has the A350 XWB and Boeing has the Boeing 787 Dreamliner. Both has over 50% composite on their body, on their structure. Why are composites important? Well, it's undeniably that composites has been a trend in building aircrafts nowadays. But why is it important in using composites in building aircrafts? Well, first and foremost, composites do not corrode. It's as simple as it being a non-metal, hence it doesn't undergo corrosion. Secondly, the structural strength of the composite is comparable to that of alloy metals, but it offers a lightweight alternative for the aircraft. What this does is that it makes the aircraft lighter, which will in turn contribute to a better fuel efficiency, which means that the aircraft could go further than a conventional aircraft. But thirdly, composites also contribute to a more pleasant environment. Um, for example, if you take the air at 8,000 feet, it's less humid than what we humans are used to here at sea level. So, to increase the humidity inside the cabin, well, it would bring about the increase of condensation rate, in which it will happen at the skin of the aircraft, which is the aluminium. This is bad because aluminium will corrode in contact with water. But if you use, say, composites, well, composites are less susceptible to condensations and they do not corrode. So yeah, I mean, it means that the cabin can be more humid than usual. It can support better humidity. Next, composites also provide a smooth surface, which means that less drag is induced to the aircraft, which means a better fuel efficiency. The aircraft can go further than normal and all that jazz. And next, composites do not crack from fatigue. Well, fatigue aircraft, they are susceptible to fatigue, in which they expand and contract every time they embark and disembark, every time they go up and down. So what it does to metals is that it will induce a condition called fatigue to the metals, which is bad. But if you use composites, it does not happen. And lastly, composites also last longer, in which it will mean less maintenance and less repair and more money for the airline. Disadvantages of using composites on aircrafts. Well, it is generally known that composites, they cost more than the conventional materials used to build an aircraft. An A350 XWB 900 would cost around 308 million, while a 707 Dreamliner would cost around 264 million. This is absurdly high, where smaller airlines, they cannot afford these types of revolutionary aircrafts. So yeah, I mean, that is bad. But the initial high cost of this aircraft would be offset by the long-term cost-saving capability of these aircrafts. Secondly, composites do not break easily. So what this means is that it is hard to tell if the interior structure of the aircraft is damaged at all. Challenges faced to utilize composites on aircraft. The biggest concern in using composites on aircraft is in this section of MRO, which is the maintenance, repair and overhaul. The maintenance requirement of composites, they are very much different from metals. So, and companies, they do not have much experience in handling composite repairs, in repairing composites. And there's also a lot of unknowns regarding the handling of composites, regarding the maintenance of composites. And there's also a lack of standardization. Uh, Furthermore, damage is easier to repair in metals as compared to composites. The uncertainty is highlighted in the report published by the GAO, or the Government Accountability Office, in 2011, in which they highlighted four uncertainties safety related, in which the first one is limited info on the behavior of the airplane composite structure. Second one is technical issues related to unique properties of composite of materials. The third one is the standardization of repair material and technique. And the fourth one is the training and awareness. Economic impact of using composites on aircrafts. The A350 XWB 900 have reported an increase in 25% of fuel efficiency, and the Boeing 787 Dreamliner has reported an increase of 20% in fuel efficiency. It is also known that 20% weight is reduced in both these aircrafts. So what it does is that it saves a lot of fuel for the airline, in which the aircraft can go further than a conventional aircraft. It is known that fuel is they make up a lot of the expenditure of the airlines. So what it does is that it saves a lot of money there for the airline. And secondly, composites do not corrode. So what it means is that less maintenance goes towards the aircraft,